So for your class, I shared the important links last night, which has everything from our remind code in case you never downloaded it, our Zoom code, how to access my YouTube channel, and then just the classroom expectations as well, which are pretty straightforward. But in here, in case you didn't see it, I have the bell schedule. Also, I made a quick file where you can just put all of your Zoom codes for your classes, so they're all in one place and you don't have to look for them. But then on classwork, so today we're going to be doing 318, the circles mock. But I also put this distance learning calendar week 1. And it puts the links to all of the assignments, but just so you know what we're doing. So Monday, for those of you that were here, we did the circle packet. I wanted you to try what you could on the circle mock, and then I gave you practice on Delta Math. Today we're going to do the circle mock, and then you can practice with Delta Math or problems from the packet from yesterday. And then I want you to highlight the vector syllabus. And so you just click on it and it'll take you to the vector syllabus. So I tried to make it as straightforward as possible. Okay, so starting with the first page of the circle mock, does anybody have any questions, or do we just want to go through all of it?
Can we just go through all of it?
Oh my gosh. Okay, yeah.
Well, we don't have to.
No, it's fine. So for the first one, 1A, does anybody know it?
1.4.
1.4. 1.4, that's it. If you don't remember that it's just the first number in front of the function, you could always, since this one is a calculator question, you could type it into your calculator, and the way you would find the amplitude is doing max, your maximum, oh my gosh, minus your minimum divided by 2.
Is there any case where we would have to do that, or can we just remember that it's the coefficient?
You can remember that it's the coefficient.
Cool.
So B, find the distance between 2 consecutive peaks of the wave. Anybody?
2 pi over 3x minus 0.1. 3, I don't know.
You were very close. It's just 2 pi over 3. So your period, the formula for that is 2 pi over b. And in this case, it is b is 3, so you have 2 pi over 3.
Where are we?
Number 1 on the circle mock. Nope. The height of a wave in meters.
I don't have that. 2 of my mocks have the same first page.
Oh, those are for next week. Those are the mixed mocks.
Okay.
So the circle mock is on Google Classroom.
Okay.
We never got a physical copy of the circle mock, right? It's
no, I hadn't finished it before you guys left. And honestly, there's not really room to write on the physical copy anyway. Or there's not much room to write on the physical copy anyway. Any questions about number 1? So I would say the hardest part of that problem is just knowing that part B, find the distance between 2 consecutive peaks of the wave, means find the period. But if you recognize that, then it shouldn't be too bad. So the next one is about a runner, and his distance north of the center of the track is given by the following function, where t is measured in seconds. How long does it take the runner to complete 1 lap? So what does it mean by how long does it take the runner to complete 1 lap? What are we looking for?
period?
The
Period.
period, yep. So we would just have 2 pi over our b, which in this case is 0.08, which is equal to 25 pi seconds. I leave things in pi normally. I think IB would accept this, but if you were to actually multiply it by pi, just make sure you round to 3 significant digits. Okay. So part B asks at what is the length of the track? So what is the length asking us for?
I mean, I feel like it would be the amplitude, but that doesn't make sense. So I
It
don't know.
would be the amplitude. If it doesn't make sense to you, it has to do with the amplitude. So the amplitude is telling us the furthest distance away from the center of the track, which our amplitude is 60, but since it's a circular track, our amplitude is the same thing as our radius. And so that would be 60, and then the distance of the track, I give up. The distance of the track would be the circumference, which would be 2 pi r. So in this case, the distance of the track would be 120 pi meters. And then the last question is, at what speed is the jogger, oh my gosh, is the runner jogging? And since we have the distance of the entire track and how long it takes them to run 1 lap around the track, we can just do distance divided by time as speed. So it would be 120 pi divided by 25 pi, which ends up being 4.8 meters per second. Any questions on that one? Cool.
No.
All right, so question 3 is without a calculator. The first question is finding the period, which we're going to distribute the 2. So our function is now 3 times the sine of 2x minus 2 pi over 3. And then we can more easily see that our b is 2. So our period would be equal to 2 pi over 2, which is just pi. The next question asks you to find the zeros for the function from 0 to 2 pi. And the key to this question is knowing where the zeros occur normally on a sine graph, because we can't use our calculator. So the places where sine of x is 0 is when x equals 0, pi, and 2 pi. And I know that because of the unit circle. Okay, so now that I have this information right here, I can set up 3 separate equations, because yeah, you can set up 3 different equations knowing that 3 sine of 2x minus 2 pi over 3 equals 0. And so this means that sine of 2x minus 2 pi over 3 equals 0 if you divide by 3. So really, since I know these values here in yellow are when sine of x equals 0, we're just going to try to get this part to equal each of those values. So we would have 3 different equations. We'll have 2x minus 2 pi over 3 equals 0. 2x minus 2 pi over 3 equals pi. And I ran out of room. 2x minus 2 pi over 3 equals 2 pi. Any questions about that much?
Was that all 3B or was that 3C as well?
This is all still just 3b, and we haven't finished it yet. But once you solve for x in these equations, then that'll be the end of 3b. So once you solve all of those equations, you get that x is equal to, what did I get? 2 pi over 6, which is pi over 3. 5 pi over 6. And 8 pi over 6, which is the same thing as 4 pi over 3.
Would we have to simplify like that?
I would, and also you have to write them as coordinates, so it would be each of these values comma 0 when you write your final answer. Okay, so for 3C, in order to sketch it, what we end up doing is we're going from 0 to 2 pi. And we know where our zeros are. And we had 3 of them, and they were at and part of the key here is knowing that the shape of the sine function would be something like this. And it wants us to show the coordinates of the max and the min. I know that this point where the max and the min happens is halfway between these 2 points. So the first one would be 7 pi over 12. And then how do I know what the y coordinate is?
Could you say how you got the x coordinate?
It's halfway between. So I added pi over 3 and 5 pi over 6 and divided by 2.
Oh, okay.
So we get 7 pi over 12, but how would we find the y coordinate?
Wouldn't you just plug that in for x?
You can plug it in for x, but I will say that takes more time because since it's a maximum, it's going to be the amplitude since there wasn't a vertical shift. So we just know that it's 3. And this one would be 13 pi over 12, comma negative 3.
Wait, so how is it 3?
It's the amplitude.
Okay.
So they told us the amplitude was 3, and since the amplitude is the distance from the maximum to the midline.
Okay.
And then there's also a maximum right here that's still within the boundaries. And this one would be 19 pi over 12, comma 3. And it doesn't come all the way back down before 2 pi. So that's what your rough sketch should look like.
Where do you get the 19 from? 19 pi?
So I just picked up on the pattern. So each time from 7 pi over 12 to 13 pi over 12, they're adding 6.
Yeah, okay.
So 13 plus 6 is 19. Any questions about number 3? Cool. Number 4. The first step is to find our amplitude. Can anybody tell me what the amplitude is?
5.
5.
Yeah, 5. Our amplitude is 5, which is our A. And the way we know that is it's because it's the y coordinate of the maximum. The thing that I know about the x coordinate of the maximum is that it's 1/4 of the period. So 2 is equal to 1/4 of the period, which is equal to 1/4 of 2 pi over b. So we end up getting that b is equal to 1/4 pi. I can go through the steps if y'all need me to, but that was just algebra.
Cool.
Okay, next page. So for number 1, I was actually working on it before you guys got on. And since A part 2 tells you to find the values of K and C, I'm going to go under the operation that they want us to write down the coordinates of A in terms of K and C. Does that make sense to everyone? So I can go ahead and say that I know that the x coordinate of A is halfway. Oh, I don't know that. Yeah, so the, so sorry, guys. So the coordinates of A would be the amplitude plus C, which we know that the amplitude is just 1. So our y coordinate would be 1 plus C. And since our x coordinate would be 1/4 of the period minus K, so it would be 2 pi minus K. Sorry, 1/2 pi, so pi over 2 minus K. Because of 1/4 times 2 pi is pi over 2. So does everybody understand that? I know it's kind of abstract, but.
Can you explain how you got that again?
Yeah, so for the y coordinate, normally the sine function, the amplitude is 1, so the maximum would normally be at 1. but this has definitely been shifted up. We just don't know by how much. So the y coordinate would be 1 plus however much we shifted it up. So that would be 1 plus c. For the x coordinate, we get that first. We know that the period, oh my goodness, that the period is equal to 2 pi over b. And then in this case, our b is just 1. There's no number in front of the x. So the period is equal to 2 pi. And the x coordinate of the first maximum is equal to 1/4 of that, which would be pi over 2. But it's also been shifted to the side. So that's how I got the minus k part. Great. Okay, now I was in the middle of this problem when you guys logged on, so I was able to do k. I haven't done c yet. But in order to find the value of k, normally, where does the sine function hit hit? That wasn't helpful, but
Is it 0 and pi and 2 pi?
okay, so we know that actually I think I can find yeah, k first. So how can I find the x coordinate of a? Based off of the graph.
It's going to be halfway between 4 pi over 3 and 0.
Yes, so it would be 4 pi over 6. So 4 pi over 6 is equal to pi over 2 minus k. So then we can find that k is equal to pi over I can't do that in my head. 3 pi over 3. Is that what I just got?
It's 4 pi over 6 because of the 4 pi over 3 and the 2 pi.
The 4 pi over 2. What?
Oh, I don't know. How is it 4 pi over 6?
We took, so the x coordinate is halfway between where the x-intercepts are. So it's 4 pi over 3 divided by 2.
Hmm.
So it's pi over 6 is k. Sorry. Is everybody okay up to there? Okay. So in order to find our c coordinate, I don't know. I think you can plug in 4 pi over 6. Okay, so let me try that. I'm experimenting, guys, so bear with me. But I think that if you plug in 4 pi over 6 and our k value. So normally we would want it to be 1 of sine of 4 pi over 6 minus pi over 6 plus c. So we get 1 is equal to the sine of pi over 2 plus c. And the sine of pi over 2 is 1. So that would mean c is 0. But I don't think that's true. So what I'm going to do is what I did last time where I caught a mistake, and I'm just going to post it on YouTube after I figure it out. Sound good?
Yep.
Okay. Sorry, fam. So for part B, finding all of the zeros, once you figure out your equation, you should be able to find all of your zeros. Oh, it's non-graphing, but knowing where sine is supposed to hit, you should be able to figure out where all of your zeros are. It should follow the same pattern of the distance between 2 pi and 4 pi over 3 and 4 pi over 3 and 0.
We're on B right now.
Yes.
Mhm.
I'm just gonna put a star next to this one on my paper, and then I'll post a video of it later. So for number 2, a sketching the graph of tangent of x. Do you guys know what it's supposed to look like?
The ones where it's like the S's kind of.
Yes, kind of like the S's. It's got the undefined functions. It looks sort of like this. Does everybody know what I'm talking about?
Yep.
Yes.
Mhm.
Okay, so really you just need to know where sine and cosine are for 0 and 2 pi to figure out where it's 1 and where it's 0 and where it's undefined. So then you just place your values. So for example, the place where it would be 0, if we start at 0, what's the coordinate on the unit circle? So if we do sine divided by cosine, it would be 0 divided by 1, which is 0. So like this. Or well, sorry, like this. Because then when you do pi over 2, when you find the tangent of pi over 2, the point should be 0, 1. And then we get 1 divided by 0, which is undefined, which means that at pi over 2, there's a asymptote. Make sense?
Yes.
So on the graph, it wants you to sketch the line y equals pi minus x. So you would start at pi. Let me do it in a different color. And then you would subtract pi over 2, 0. It would look something like that, which is very difficult for me to do perfectly, but as long as you label your axes, it should be pretty easy. So if this happens at pi over 2, this y value right here should be pi over 2. And then here, this hits at pi, it should be hitting right there. And then this one should be at negative pi over 2. And this should be at 2 pi. So as long as you label it, you're fine. All I'm doing is using the unit circle for that.
So we basically just make the line hit all of the asymptotes.
Yes.
Cool.
Okay, so for part B, it says consider the equation x plus tan of x equals pi. So you can rewrite that equation. We're just talking about where the intercepts are. So it would be anywhere they intercept the asymptotes would be your solutions. Does that make sense to everyone?
Mhm.
Can you repeat that, please?
Yeah. So basically what they did, if you have the equation that they gave you, x plus tan of x equals pi, and you were to solve it for tan of x, you would get tan of x equals pi minus x, which is what we just graphed. So if we're saying where are they equal, it would be the places where they intercept the function.
Okay, thank you.
And then part C,
Are we skipping part B?
that
Or did
was
we
part
just-
B.
Oh, that was part B. I'm just dumb. Cool.
So for part C, write down the values of cosine of pi over 2 minus a. So if you were to start with your function at pi over 2 minus a, so pi over 2 is up here. And it says that cosine of a, so let's say a is over here. So if you were to do pi of 2 minus that, this is just using what's called reference angles. Do you guys remember learning those?
No.
Mhm.
Angles, like it's when you add 180 to an angle or something.
Yes, that is it indeed. So basically what you're doing is what is the cosine of pi over 2 is so this would be 0, 1. So the cosine of pi over 2 minus an angle would just be the negative of that angle. And then sine would be 1 minus the angle.
Can you repeat that? My audio just cut out for a second.
Yeah, that's fine. So cosine would be 0 minus the angle, which is just the negative angle, and then sine would be 1 minus the angle.
Thank you.
And then they want you to show that tangent is this. So I would start by redefining tangent as sine over cosine. So I could have sine of pi over 2 minus a over cosine pi over 2 minus a. Which we just got, we just said this was 1 minus s over negative c, right? I think. This is another one, guys. I might have done something wrong. I'm gonna put a star by it and come back to it and then just reteach it to you guys. Sorry. I
It seems right.
I mean, well, you have to keep going. I like stopped in the middle of the problem because I started getting it wrong. We have to get it to be 1 over the tangent of A, which would be cosine over sine, and negative C. I think it has to do with the identity of, you're going to have to use the sine squared plus cosine squared equals 1 identity, but I don't know that that's right off the top of my head, so I'm going to not teach it to you wrong and instead wait to teach it to you guys correctly. Sorry, 6 preps online has not been easy to keep up with. And it's only day 2. Okay, so moving on to the next problem, you have a diagram shows a circle with center O and a radius of 7 centimeters. The chord subtends angle 1.4 radians at the center of the circle. Find the area of the shaded region. So what you would do is you would find the area of the arc, which is equal to 1/2 theta r squared, right?
Mhm.
I'll have my formula sheet right in front of me.
Oh, I have no idea. That just seems right.
That just sounds right. I do have it over here somewhere. Yes, I was right. Okay, so once you have the area of the arc, that would give you the shaded region of the entire pizza slice. So then you have to subtract the area of the triangle, which the area of the triangle the non-shaded triangle would be 1/2 base times height, which happens to be r squared.
We have to do all these circle problems in radians.
Yes.
Cool.
Most, if not all. Times, sorry, 1/2 r squared times the sine of theta. And then you would do the first one, so the area of the arc minus the area of the triangle. And that would give you your answer. In order to find the perimeter, you would do the length of the arc plus the chord. Which we can find the chord just by doing finding the third side of the triangle. So the length of the arc is equal to theta r plus the length of the third side of the triangle. We can find using cosine rule. So that would be, let's call it x. I'm just going to do this over here, sorry. This would be x squared is equal to r squared plus r squared minus 2r squared cosine of theta. which we have all those numbers. You're just needing to plug them in. Any questions about that? I know I'm not walking you through the answer. I'm just walking you through how to set it up, but
Good.
okay.
Is that r squared plus r squared?
Yes.
Okay.
Minus 2r squared cosine of theta.
Mm.
Okay. So the next one goes through a triangle with 2 arcs. And then you have to calculate the area of the segment BDCP. So the first thing I would do is find the length of the arc. So you can find that length, the area of that arc. So since A is the center on that one, we use the number 2. So the area would be 1/2 theta, which our theta in this case is 90 degrees. But we have to put it in terms of radians. So 90 degrees in terms of radians is pi over 2. And then our radius is 2 squared. So that would give me the area between A, B, D, C. Is everybody following that? Okay. So then I would have to subtract the area of the triangle. Which, since it's a right triangle, we can just do 1/2 base times height, which would be 1/2 times 4. So pi minus 2, is that what I'm getting? So that would be the answer to part A.
Cool.
So we can figure out the larger arc. So the larger arc, since P is the center, we just have to find the third side, so BC, which would be equal to 2 squared plus 2 squared equals BC squared. So we would get 8 is equal to BC squared. So BC is equal to 4. Is equal to the square root of 8. Goodness, somebody stop me when I say stuff like that. Which is the same thing as 4 root 2. 2 root 2. Guys, it's been a long day, and it's like what, 11 o'clock, 12 o'clock? So that's equal to the entire side BC. But we can find the radius then by just calculating B to P. So B to P is equal to half of BC, which means that it's equal to square root of 2. So that's the radius for the bigger circle. So we can find the length of that, the area of that arc. And so we do 1/2. And in this case, our theta, since it's 180 degrees, our theta would be pi. And then our r is square root of 2 squared. So the area of the bigger circle would be pi. So in order to find the shaded region, we would do pi minus the area of ABDC, which was pi. So I got pi minus pi, which is 0. So that can't be right. Did anybody see where I went wrong?
My question is, when we're doing the area of the bigger circle,
Mhm.
we're pretending that it's a full circle and not just that little part.
Wait, sorry, say that again.
When you did 1/2 times pi times the square root of 2 squared, why did you do that?
So since I'm trying to do the length of the arc from BE to C.
Okay.
So the radius would be equal to the distance from P to E is the same thing as the distance from B to P, which would be the square root of 2.
Okay.
So that's our radius. And so I'm getting square root of 2 squared is 2, divided by 2 is 1, so that should be pi.
Okay.
But then I should be able to subtract the area of BACD or ABDC, the white area, which we found at the beginning, which should have been 1/2 pi over 2 because it's a 90-degree angle. And then our radius was 2 squared. So that would be 4 divided by 2, which is 2, times pi over 2, which is pi. So I keep on getting that it's 0.
Why was pi the angle or
For
theta?
the second one, because it's, if you look at P, instead of a pizza slice, it's like half of a pizza, half of a circle. So the angle is 180 degrees right there.
Okay. Cool.
Which would mean it's pi. I'll put a star next to it. I'm so glad this has been an effective class for both you and me. I'm so mad right now. Okay. What time does this class end for y'all? 12:20?
12:25.
Okay.
I think. Yes.
3A, write
Can
down
always end early. I'm just saying.
I am thinking about it, honestly, because it's not necessarily beneficial for me to keep teaching the wrong thing.
It ends at 12:20.
Okay.
Does it?
Yeah, I just checked the
Last
schedule.
day, right?
Oh, mine. The schedule that was sent out by Miss Marquez is 12:25.
Oh, Dr. Height's schedule says 12:20. And lunch
Okay.
starts at 12:25.
My
That's
money's
good.
on Dr. Hyde every time. I'm just saying.
Don't listen to me then. That's cool.
The diagram, write a minimum value of cosine of x and the smallest possible value of x in radians for which the minimum occurs. So what's the smallest value of cosine of x? Anybody? Okay, so if there's no alterations to the function, that means we're operating basically under the unit circle. So the minimum value would be -1. So for part A, the min is -1. And then we just have to figure out at what x value does cosine of x equal -1. And the smallest value where that happens is where x equals pi. Yay, I did something right.
Good job, Ms. Thompson. You do a lot of things right.
Thanks so much. Okay, so part B, describe two transformations which transform the graph of y equals cosine of x to the graph 2 cosine x plus pi over 6. So what does the 2 do to the function?
Changes the amplitude.
It changes the amplitude. And what kind of, if we were just talking about the graphs in general, what type of transformation is that?
Vertical
It's a vertical stretch.
stretch.
Yeah. So, so for part B, this is a vertical stretch by 2. And then what does that pi over 6 part do? Is it horizontal or vertical?
shift.
It's a horizontal shift. And which direction is it?
Left.
Yes, it is left. Okay, so hints state the minimum value of 2 cosine x plus pi over 6 and find the value where it occurs. So what would the new minimum be if we stretched it by 2?
-2.
Mm-hmm. So our new C would be, so it would be -2 is the min. And at what x value does it occur? So we started, oh my gosh. Since we started at pi and then we moved to the left pi over 6, that means we're now at 5 pi. This is where it's going to happen. So C1 is where it would have any vertical asymptotes. What has to happen for there to be a vertical asymptote?
Isn't that when the denominator equals 0?
Yes. So we're going to find the value where it equals 0. Normally, where does cosine of x equal 0? We're going to use the same pattern basically that we just did. So cosine of x would equal 0 at pi over 2 and at 3 pi over 2. Now we have shifted to the left pi over 6. How do I do the +3 though? Oh, sorry, I'm so sorry. So what would the minimum value be for this one? It would be -2. But if it shifted up 3, all of the values would be positive. So would it have any zeros?
No.
No. So that would be the answer. And then you'd explain why. So if the minimum is -2 and it's shifted up 3, then the function would never, the denominator of the function would never equal 0. So then finding the range of f would be the maximum y value. So the maximum for the denominator would be 2 plus 3 is 5, and then 5 divided by 5 is 1. And the minimum value would be 5 divided by 1, which is 5. So we would have 1 to 5.
So it's both of those, 5 to 1, and then 1 to
It's
5.
just this one. I just wrote it in the wrong order.
Oh,
We have to use brackets every time we denote range.
If the number is included, yes, you should. And it will hit 1 and it will hit 5. It doesn't get close to those numbers.
can you go over how you found those values?
Yes. So I found the minimum of the denominator. Like, so what the lowest y value possibly could be. So if we plugged in pi for x, then you would get -1. And -2 plus 3 is 1. And 5 divided by 1 is 5. And then on the other end, you could get +1. And +1 times 2 plus 3 is +5. And 5 divided by 5 is 1.
What was the answer to C? I didn't write it down.
So the answer for that one was no, there aren't any vertical asymptotes. And the reason why is because the minimum value for the function, for the denominator of the function would be -1. And then -1 times 2 plus 3 is a positive number, which means it never crosses the x-axis.
Thank you.
You're welcome. Okay. Last one, best one. Well, last two, but last page. Thomas, Sebastian, are y'all dead?
No, I'm here.
No,
Okay.
we're still here.
Just making sure. Just haven't heard from you in a while.
Sorry.
No, it's okay. I'm just making sure. The two circles have equal radius r and intersects at point S and T. The centers of the circle are A and B, and ASB is 90 degrees. Explain why SAT is also 90 degrees. So for this problem, the first thing I would do is draw a picture. Okay, I'm gonna try. And they intersect at points S and at points T. And the centers of the circle are A and B.
Ms. Thompson, I really missed Venn diagrams. Thank you.
Oh, well, you're so welcome. So it says that angle ASB, so that would be this, is 90 degrees. And then it wants us to explain why SAT is also 90 degrees.
Can this just be like side angle side?
Yes, sort of. Yes, it is. So the congruency would be because since the radii are equal, if this is R and this is R and this is R, then the angles between them have to be the same. Basically what this means is that there is a square, and since all four sides are equal, then all four angles are 90 degrees. Or you could do two similar triangles if you wanted to. Okay, then it wants us to find the length of AB in terms of R, which we just talked about these being similar triangles. So it's a 45, 45, 90. And since it's a 90, we can just use Pythagorean's theorem. So we get R squared plus R squared equals AB squared. And so it's the square root of 2R squared. Which I guess you could simplify to be R square root 2 as well. And then it wants you to find the area of the sector AST, which you just use your area formula, which is 1/2. Theta is 90 degrees, which how do we write that in terms of radians?
Pi over 2.
Yep. So we have pi over 2 R squared. And then finding the area of overlap in the circles. So I'm going to draw another diagonal here down the middle. So if you found, let me try to do this with a highlighter. If you find this area of this circle and you subtracted this inner triangle, you would get just this light blue section right here. Does that make sense? So if you do the area of the sector minus the area of the triangle, you would get 1/2 of that little Venn diagram. So then you would multiply that answer by 2 to find where it overlaps.
Okay. All right.
I forfeit. Okay. The last question, the diagram. Actually, our class is about to end for lunch. So I'm going to save this last question and the questions that I absolutely messed up, and I'll make sure I have them ready for Friday. But don't forget, your homework for tonight is to look at these problems and look at your circle packet or Delta Math if you're feeling uncomfortable about these, and also to highlight the vector syllabus. So you'll highlight things yellow for stuff you don't think you've ever seen, and blue is highlighting stuff that you learned but don't really remember. Okay? And then you'll just submit that on Google Classroom so that I can see it before Friday, so I know what best to focus on for you. Okay? Any questions? Okay, then have a great day.
See ya.
Bye.
Bye. Thank you.
Bye.